extension article we're going to do.
Alrighty, so yesterday we did slope-intercept form. And not surprisingly, you use slope-intercept form when you have a slope and you have an intercept. What we're going to do today, we're going to talk about point-slope form. You use point-slope when you have a slope and a point. Okay? Here is point-slope form. Y minus y1 equals m times x minus x1. Let me show you where this comes from. Remember your slope formula from yesterday. Slope is the change in y over the change in x. Now let's just say we have a general case, and instead of a specific y2 and x2, we're going to have a general case of x and y. So I'm just going to write this as m equals y minus y1 over x minus x1. So x and y are just our general case. Now you guys know that if you're solving and you want to get something out of the denominator, a denominator indicates division. So to undo division, you have to, multiply. So if I multiplied both sides by x minus x1, I would get rid of that denominator. These would cancel, and I would have m times x minus x1 equals y minus y1. So all I did was I took my slope formula, I put in a general case of x and y, and then I rearranged my numbers so it looks a little bit different. And you guys know that the symmetric property means that I can switch those two equal values onto other sides of the equation. So I can write this as y minus y1 equals m times x minus x1. That should look familiar.
Thank you.
You're welcome. That's where this comes from. Now I'm probably not going to ask you that on a test, but just so you have some kind of an idea that we just didn't come up with this out of nowhere. It's coming from your slope equation to have this formula for another way to write an equation of a line. So here we are with problem 1, writing an equation when given a point and the slope. So that is the sign that you need to, use point slope. You're given the point and the slope. Use point slope. The line passes through negative 5, 2. So that is your x1, y1. The slope is 3 over 5. That's your m value. What's the equation? So your point slope form is y minus y1 equals m times x minus x1. Fill in everything that you know. We know that y1 is 2, so y minus 2 equals m, our slope is 3/5, times x minus x1. Minus negative 5 is plus 5. So there you go. That is in point slope form. Now it doesn't specify what form they want you to end in. It just says what's the equation of the line. If it's not specified, you should usually just end up putting it into slope-intercept form, because that's pretty much the easiest one there is to work with. So let's just take this one step forward, solve for y so it's in slope-intercept form. Y minus 2 equals 3/5 times x is 3 over 5x. 3/5 times 5 is just 3. And then one more step to solve for y. Add 2. So we get that y equals 3 over 5x plus 5. Cameron. Plus 3, I multiplied 3/5 times x and 3/5 times 5. So 3/5 times 5. These guys cancel, and I get 3/1. Make sense? Good. There's your equation of the line. What's the equation of a line through 7, -1 with a slope of -3? So this is your x1, y1. Your m is -3. Y minus y1 equals m times x minus x1. Do you have to write that every time? No. I'm just putting it there to help you guys out. Because the more you see it, the more you'll remember it. Y minus -1 is y plus 1. Equals m, which is -3, times x minus x1 is 7. So right there, we have point-slope form. Let's simplify it some more so we can make it into slope-intercept form. Y plus 1 equals -3x plus 21. Just solve for y. Y equals -3x plus 20. Write the equation given 2 points. Well, if we're given 2 points, what vital piece of information are we missing? Because so far we only have 2 equations, slope-intercept and point-slope. Cameron, what are we missing? Slope. But you have 2 points, so you can find slope. Change in y over change in x. So our line passes through 3, 2, and 5, 8. First, I'm going to find my slope, y2 minus y1 over x2 minus x1. Your slope is 3. Once you have your slope, you can choose either point. It does not matter. Personally, I choose whichever one looks easier to deal with. These look about the same. I'll just pick 3, 2. So we have our slope and our point. Y minus y1 equals m times x minus x1. Y minus 2 equals 3 times x minus 3. And this time it's asking you what is an equation of the line in point-slope form. So you just want to stop right there because it asked for point-slope form. That's it. A line passes through -5, 0, and 0, 7. What's the equation of the line? In point-slope form. First, find your slope. 7 minus 0 over 0 minus -5. Slope is 7 over 5. Choose whichever ordered pair you want. Which one do you guys want? -5, 0 or 0, 7? 0, 7. I knew it. No one likes negatives. All right, so we're going to use 0, 7 as our point. We're going to use 7/5 as our slope. Y minus y1 equals m times x minus x1. Y minus 7 equals m times x minus x1. That m is 7/5. Now, if we have x minus 0, do we really need to write anything? No. We could just have x. So y minus 7 equals 7/5x. And that is your point-slope form of that equation.
Wait, don't you have to get y by itself?
You do, but usually you do, but this one says in point-slope form. Since it's asking for point-slope form, you stay right there. Slope-intercept form is when you have y by itself.
I thought. Oh wait, never mind.
Now this reasoning question says, what's another equation in point-slope form of the line through those same points? What'd you say?
So you just use the other one?
Yeah, because even if you switch these around and you said that 0, 7 was your x1, y1, you're still going to end up with the same slope, no matter what. So if I still have to use this slope of 7/5, like Jordan said, we could just use the other ordered pair, -5, 0. Well, let's see what happens. If I would do y minus y1, that's y minus 0, equals m times x minus x1, gives me x plus 5. And again, I don't need minus 0. I can just write y equals 7/5 times the quantity x plus 5. So that's another equation. That's just what the question asked. Now I have an issue with this. Because if this is the exact same line through the exact same points with the exact same slope, why do I have two different equations? We use the same points, they have the same slope, but I've got two different equations. Why, Jess? It's not. Because if it's the same line, it has to have the same y-intercept. Julius?
Different forms?
Yeah, they're just written in different forms here.
Even its final form.
If it's in the final form of slope-intercept, it's going to look the exact same. Look, if we took the blue equation and added 7 to both sides, then I would end up with y equals 7/5 x plus 7. That's in slope-intercept form. If I wanted to put my red equation in slope-intercept form, I would distribute the slope, and I would have y equals 7/5x. 7/5 times 5 is 7. Voila. They're the exact same. They just weren't solved for the same variable. They both weren't solved for y, so they looked different. In point-slope form, they look different. But they are the same lines, so ultimately they're going to have the same equation in slope-intercept form. One more form to talk about, and that is standard form. Standard form is ax plus by equals c, where a and b can't be 0 at the same time, meaning we have to have an x and or a y value. Because if a and b were both 0, we wouldn't have an x or a y. 1 is allowed to be 0, but we cannot have both a and b be 0 because then we would not have any x's or y's. For a standard form of an equation, you should not have fractions or decimals. Okay? Sometimes it will be very specific in your question and indicate that, but sometimes it will not. It will just expect you to know that with standard form, you should not have fractions or decimals. So I would take note of that. Standard form, no fractions or decimals. What's the equation of the line y equals 3/4x minus 5 in standard form? Standard form is pretty easy because all you're doing is rearranging the order. You're not really plugging in your slope or points or anything of that sort. You're just rearranging the order. But we don't want fractions or decimals. So how do you guys think I could get rid of this fraction of 3/4? Christy? Exactly. You don't want the denominator of 4, so take it away by multiplying both sides by 4. Four y equals 3x minus 20. If you're multiplying the right-hand side by 4, each term gets multiplied by 4. So now we've done away with our fraction, which is great. Now we need to get it in standard form. So we need to have it as ax plus by equals c. I am going to subtract 3x from both sides. And I end up with negative 3x plus 4y equals negative 20. And that's your standard form of the equation. Your x plus y equals a number is standard form. We have the line y equals 9.1x plus 3.6. We want it in standard form. But let's get rid of the decimal first. Morgan.
Multiply by 10.
Very good. What you do to one side, you must do to the other. $10y equals 91x plus 36. What would I need to do to get it into standard form? Yu-Chen. Very good. And can somebody tell me the standard form of this equation? Cody.
Negative 91x plus 10y equals 36.
Very good. And the last slide that we're going to do kind of a wrap up of all the forms that we've done. We talked about slope-intercept yesterday, obviously using the slope and the intercept. We talked about point-slope today, using a point and a slope. Remember, for point-slope, if you don't have a slope, if you only have two points, you have to find it. And then standard form, just talking about ax plus by equals c. Your homework for today